Okay, so today, guys, 9D.2, it's a short, sharp exercise. So we've had a little bit of delay at the start, that's fine. We'll get straight into 9D.2. I would anticipate either sort of finishing this before recess, giving us that second lesson dedicated to the folio. So when we come back from recess, we'll have a group chat about where we're at with the folio. I've got 3 more drafts to do, which means most people have their drafts already. So let's get straight into this here. What we're doing is we're taking the formula that we have for a confidence interval and we're rearranging it to get n by itself, that is the number of people we need to sample, the number of samples we need to perform, in order to have a certain width. So remember yesterday how we had the confidence interval? All right, let's just get straight into the question. The height of 40 year 12 students is measured, the mean was 178, the standard deviation was 8. So we saw yesterday with the 95% confidence interval that the confidence interval was, I don't have it written down, what does it say on the left hand page for the 95?
196.
196? Oh, not the number, the confidence interval we found. I think it was 176 to 180 or something. Is that correct for the 95% confidence interval?
175 to 180.
175 to 180. Thank you. Thanks, Jeffy. So 175 to 180, and this has a width. The width of this confidence interval is 5 units. Okay. The distance from the lower boundary to the upper boundary is 5. Now the question says to us, how many people do we need to sample in order to have a width of 2 centimeters? So that we're super confident. All right, we want to be more confident. How many do we need to sample so that we have a width of 2 centimeters, so that we have a very narrow window for where the true mean lies? And we're just using this formula. N is 2 times 1.96 divided by the width squared. Okay? So the 1.96, we know that's for 95% confidence. So we also know from this formula, we could figure out the number for other levels of confidence as well, right? The 1.96, we could substitute it for the 2.58 to be 99. Anyway, the question's asked for the 95, so we'll stick with the 95. So we need to sample 2 times 1.96 divided by, what's the width? 2 squared. What am I missing though?
Standard deviation.
The standard deviation. I was going to say, that doesn't look very large at all. Times the standard deviation. There we go, thank you. It's tucked away in there. All right, so we'll crank that in our calculator. So 1.96 times 8 squared. $245.8. $246. Okay, now this is a type of question where, regardless, now this is technically speaking, although SACE will accept either, regardless of what this decimal is, you round up because we want to guarantee a certain level of confidence. If we're rounding that down, then we're not going to maintain that same level of confidence. Okay? So regardless of what the decimal is, you round it up. In this circumstance, it rounds up anyway, but SACE will always accept standard rounding. Okay? So it doesn't matter if it doesn't really affect you. I'm just saying, technically speaking, you round up. So that when you see in the practice test, that's what I've done. I'm rounding up consistently. That's going to be the justification as to why. All right, so pretty straightforward skill. Just putting that in the formula, finding values of n. We'll have other levels of confidence pop up as well. Just change that 1.96 number. Any questions? All right, let's rip through it.